Hi, it's me again. So this time we're going to work with the GDC question. Let me get my calculator first. Yeah, here we come back. We are using our Casio calculator. And yeah, you can see it's still in exam mode. All right, so I'm still waiting for the 24 hours to get it over because Alan is a student. All right, so let's do this. So the coefficient of x to the power 5, so this is 5. So all you need is x5, 3, 2, because it's 3 and 2. Make sure your bracket is outside. And then it's 7, 5 or 2 doesn't matter because it is symmetrical. Yeah, that's the word. So what we're going to do is we get to our calculator. I got my normal calculation bit, the matrix. And then we need to find the NCR. So all you can do is you go to option. Oh, by the way, what I'm doing is just one of the way, and I'm using Casio not FG, FXCG50. All right, and yeah, when I got other sponsor, I'll use other calculator. Just still, this is not sponsored, so I'm using mine. And this is the NCR. Repeat again. So you go to option. It's not here. We go to next page. You can see probability. So you click on the probability. It's all you want here. So we have 7C2. They will give us our 21. So we will have 21 times 9. So that gives us 189. So we make sure you write down the answer correctly. All right. And they ask for the coefficient. So write down the coefficient. All right, next bit. They want the x to the power 4, so which means that negative 3x to the power 4. And then we have 5 here, 7, 4. So 7 minus 4 is 3. All right, again, this one, I'm going to press it in one go. You can do this in one go, so let me put it here on the side. I have 7C4 times 5 to the power 4 times, make sure you come down, otherwise it's wrong, and negative 3 to the power 4. Remember, it's a positive index, so we can get through the, I got it wrong. Sorry, it's a 3. So Casio got this thing, and you can move up and fix it. Now is the answer. 3, 5, 4, 3, 7, 5, x to the power 4. Therefore, the coefficient is 3, 5, 4, 3, 5. All right, this is a long number, so I'm going to store it somewhere. So what you're going to do is like I press the arrow here, answer arrow, alpha A. This will means that my answer is stored in the memory of A there, the cabinet of A. So let's move on. Use the above result, find the coefficient of x to the power 5 when you do this. So we want the coefficient of 5. So it's 189x to the power 5 minus x times 35437x to the power 4. So which means that my answer will add them up. We will have to have 189 minus whatever I store in A. And that will be the answer. So we have negative 354186. All right, so a recap. To find the NCR, option, next page, probability, and you can find your NCR there. All right, second, when you like a number, you can store it in arrow, answer arrow, alpha A. And then you do all those silly things, your alpha A still is the answer, you store them. All right, unless you override it, the number will still there. So that's a bit of the little calculator skills sharing. Until next time.
Right, here's another question, which we have a 6-mark question, which we are going to work with financial maths here with the GDC. So we have Aaron, that person who put P dollars into the bank annually, 7.5%, but compounded monthly for 9 years. So we got all the information, and 9 years later, we got that. So we could do this part with the formula we have. So we got the A there, and then we will have P dollars times 1 plus 77.3%, which is, we round it, we change it to decimal, that becomes 0.073 divided by 12 because it's monthly compound. And because of 9 year, 9 times 12, that gives us 209,000. All right, so all you need to do is put it to the other side to divide if you're using the formula there. So we could have 29, oh, that's long, equals to 290,000 divided by 1 plus 0.073 over 12, 9 times 12. All right, and then with the formula, we'll quickly use our calculator function, and then we just put that in. 1 plus bracket, no, we need the bracket out there. 1 plus 0.73, that is the percentage, over 12, everything to the power to 9 times 12. I like the Casio GDC because it works so great. And this is the answer there. So this should be equals to 150636 times and more. But we want it to be rounded to integer, so be careful with those. Usually papers is 365, but then this time we have it with the integer, and this is the amount we have for P. The other way we could use is the function of the financial math. So we go to manual, and then we go to finance, C there, and then we could have the compound interest. All right, we need to key in whatever we have. So number of time is 9 times 12, that is the number of time they compound. Percentage, that is get it in, so this time is 7.3. You do not have to change it to decimal. PV is what we want, so we leave it for now. MPMT is like monthly payment, so we don't know. So at the end, we should have 9,000. Payment per year is 12, and compound per year is 12. For the working, if you're using the calculator, you have to list out all the things there. But you don't have PV, we don't have that. But then FV, future value, PY is 12, CY is 12. This is how we list out all the things as our working. And now we put previous value. PV will give us negative 150,636.7 more. But then we want the integer, and previous value for the calculator is money taken out from you. So now P should be equal, from the question, should be equals to 15063 rounding to the integer, and that is the answer. So either way should work. And then part B. Aaron put those money to a car, and sometimes later it depreciate. So when we depreciate, it is a minus. So we have to have 1 minus 6.25% equals to 205,000. So where this time at this power T, we do not know how many years we got. So we have to do it without the calculator. Not the app though. So we have 20. Now we can simplify the dollar sign. So it's 205,000 over 2912344 zeros there. This is the base, so we have the log 1 minus 0.065, and then 205,000 over 29. All right, so you might want to remember when we have AX equals to N, then the log, base stay base, and then N is here, the index will get to you. So this is how we get that. So again, with the calculator, this time we go back to our calculation matrix, and then we have to log AB. To find the log different base, either you can go to math and you look it up from here, or you can go to option cal. Not here, next page. It works the same. So we have 1 minus 0.065 0.065, and then the fraction there. Sorry, I forgot to bracket. Alright, so it's 0.95 there, so we just do it one more time. 0.635, and then over a fraction 205,123 over 1234. That should give me the answer. Yes, so T should be 5.1610 da, 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 da. This didn't say anything, so we will have it with the 3 sig fig there. And this is our question with financial math. Right, so here is a question there. So I really like this question because it's like the complexity of the binomial expansion. Like usually it's easy to go to catching point bit, but yeah, this is really cool. Oh, so let's do this together. So we have the first term, power 7, and power x, no, power 1, with the 2 terms there. So first 2 bit is pretty easy to catch, so it's easy. So first term, no matter which side you're counting from, we can always look at this. So we have the 8a7. No, we cannot write this because that will be working backwards. So let's do this. Oh, so we have the x to the power 7 here, so which means that the a, sorry, not b. The ax have to be 7. And b is 1. So with that, we have our 8, 1. Either way, 7 or 1 doesn't matter, it's still 7. So I know it's 8 because the Pascal triangle comes with like 1, 1, 2, 1. The second one, 0, 1. The first NC1 should always be the same number as n. But just in case, so we go to option, probability, NCR. Oh, sorry, 8C1. That gives us 8. So no brainer, a x to the power 7, x to the power 7, b. The only issue is some of the students forgot to share the x to the power 7 to both sides. So that make it wrong, unfortunately. So next bit, we're going to find the other one. So we will have the other one. So it's a ax to be 1, so b should be 7. And then 8, 7. All right. I know it's 8 anyway, so we still have to try it just in case. So 8c7, they give us 8 as well. So 8xb7. So we got two terms there already, 5 points in our pocket. So now here, with the information we given, we need to find a and b. This is a latest classic there. So we have power 7, the top one. So we have -5, 1, 2, 0, x to the power 7 equals to 8a7 x7b. So we simulate that and divide 512, -5, 1, 2, 0 divided by 8. That gives us -640 equals to a7b. All right, so this is our first one. And the other one, we could have -1, 2, 5, 1, 2, 3, 4 x equals to 8xb7. So again, we cancel the x and divide it by, so -1, 2, 5, 1, 2, 3, 4 divided by 8. That should be -156,250 equals to AB7. All right, so here we go, we got that. And we can do all the maths there, but then what I'll do is divide both there because they should have the same R there. So let's see. So I have A7, B7, B, sorry. I'll leave the numerator as the, and -640 over AB7 over -156,250. All right, so we cancel that out. So that will be 6, and that will be 6. And then we have -640 over -156,250. Yeah, yes, there we go. So now we have A6, B6 equals to 64 cancel the 0 already, over 156250. All right, if I use the index law here, a over b to the power 6 will be equal to 64 over 156250, which means that if I 6 root it, I get 2 over 5. Remember, it's even index, so it's plus or minus. That is the painful bit. So we have plus or minus 2 for A, and B is plus or minus 5 for B. However, we need to test it out what it's going to be. So we're going to have no, actually we can't do this. Yeah. So now we have A over B equals to 2 over 5 plus or minus. So which means that A will be equals to plus or minus 2 over 5 B. Am I right? Yes. So we need to test out both situations. So for A equals to this bit, let's use this one, the nicer one. So 640 equals to positive, A equals to 25, positive 25B power 7B. No, that's a bit painful. Nah, never mind. So we will have 2, 7, and then maybe I changed my mind. Let's do the B then. Sorry. Oh, let's do the B there. So A and 5 over 2 would be equals to B, plus or minus. Yeah, that would feel better. So now I substitute it back to the same equation. So I will have say negative 640 equals to A to the power 7 times, say for the positive one. So we will have 5 over 2A. So that gives us A to the power 8, negative 640 times 2 to the power 5, A to the power 8. This won't happen because we will not have a negative answer there. So, and it's not finished yet. We need to try the negative as well. So we got another piece of paper. Oh, I just need a lot of paper. So we will have negative 640 times negative 2 over 5. Let's skip that. Equals to A to the power 7 times negative 5 over 2A. Alright, so this case, we will have A to the power 8 and then divide by negative 640 times 2 over negative 5. That gives us a positive number, which is a nice thing. So our calculator, 640 times 2 over 5. I skipped the negative because it's become positive. So we come 256 equals to A to the power 8. A now become plus or minus 2. Oh, what a pain. So now we will have B, because the other one, where is it? The other one will not have a solution. We will have this one as a solution. So A will be B will be equal to negative 5 over 2A. So we need to find B back. So when A equals to 2, B will be negative 5 over 2 times 2 equals to negative 5. When A equals to negative 2, B equals to negative 5 over 2 times 2, positive. So they give us cancelled out, so they give us 5. So we got 2 sets of answer there. Whoa, what a pain. So these is a bit bright there. Alright, so that is the 2 answer we have there, and finally we get that right. That's why I like this question. Alright, until next time, coming up will be some past paper of IB, so stay tuned. No, that's my